The Alborz mountain range runs along the southern shore of the Caspian Sea like a spine, 2,000 meters of continuous elevation that separates the humid green coast from the dry Iranian plateau below. From the plateau side, the mountains present a wall. From the air, they present something more useful to a military planner, a geological mass so dense, so continuous, and so deep that anything buried inside it occupies a category of protection that no surface installation can replicate at any cost. The Iranian Air Defense Force understood this the same way every serious military organization understands geography, not as scenery, but as infrastructure. What they built inside a specific ridge of the central Alborz over 13 years of construction that the satellite imagery analysts had been arguing about since the first excavation spoil appeared on the surface was not a radar station, not a missile battery, not a communications relay. It was the brain. The underground facility beneath the Alborz Ridge housed the primary command and control node for the entire Iranian Integrated Air Defense System, the IADS, the networked architecture of radars, missile batteries, fighter intercept controllers, and electronic warfare assets that covered Iranian airspace from the Iraqi border to the Pakistani frontier and from the Gulf of Oman to the Caspian coast. Every sensor feed in the Iranian air defense network was routed through this facility. Every engagement authorization for the S-300 and Bavar 373 batteries that formed the strategic layer of the defense passed through the command consoles inside this mountain. Every intercept order for the fighter squadrons that formed the kinetic backup to the missile layer originated here. The facility was not merely important to the Iranian air defense architecture. It was the Iranian air defense architecture. Everything else, every battery, every radar, every fighter on alert, was a peripheral. This was the center. They had protected it accordingly. A ring of Tor M1 point defense batteries covered the approach corridors into the Alborz with overlapping engagement envelopes extending to the ceiling altitude of any delivering aircraft. Beyond that inner ring, 2 Bavar 373 batteries on adjacent ridgelines provided long-range coverage of the approach corridors that terrain channeled into 3 valleys, valleys whose geometry had been mapped, modeled, and defended with the specific purpose of making them untenable. An S-300 PMU-2 battery on the plateau below the northern face covered the higher altitude southern approach from the direction of the Persian Gulf. The facility's defense had been built outward from a precise threat assessment, American stealth aircraft specifically. The designers had studied that problem and built their solution accordingly. The target folder that established the facility's existence, confirmed its function, and mapped its internal layout and external defense architecture had been assembled over 5 years. What it produced, when the analysts were satisfied the picture was complete, was a document describing a facility whose destruction would reduce the Iranian IADS from an integrated, networked architecture to a collection of individual systems operating without common situational awareness, without coordinated engagement authority, and without the ability to share sensor data across the battle space. Individual systems, capable systems, many of them, but systems operating in isolation rather than coordination, which in air defense terms is the difference between a wall and a collection of bricks. The operational implication of that difference was the reason the targeting decision was made. The mission that was built around the target folder was unusual in its architecture for a reason that the planners discussed at length before resolving it. The facility's function as the command node for the entire IADS meant that its destruction would, in the moments following the strike, create a window of degraded Iranian air defense capability across the entire country. That window had a duration, the time it would take the Iranian IADS to reconstitute command authority through its backup protocols, which the intelligence assessment estimated at between 40 and 70 minutes, depending on how effectively the backup nodes had been maintained. The mission planners had to decide whether the strike package would use that window. The decision was made to use it. The B-2, carrying the primary weapon, would be accompanied by a second asset, whose mission was not to strike the Alborz facility, but to exploit the degraded IADS window for a reconnaissance pass over 3 secondary targets whose status the intelligence community had been unable to establish. The second asset carried sensors, not weapons. It would fly deeper into Iranian airspace than any reconnaissance platform had in 8 years, collect what it needed, and egress before the IADS reconstituted. The B-2 carried a single GBU-57 massive ordnance penetrator in the forward bay and a secondary precision weapon in the aft station, a smaller system targeting the facility's backup power infrastructure, a hardened vault located 140 meters from the primary command node. The backup power vault was not as deep as the primary chamber. The secondary weapon could reach it. The planners included it because a facility can survive destruction of its primary function space if power infrastructure remains intact. Personnel can operate from backup spaces while damage is assessed, and partial reconstitution is attempted. Eliminating the backup power vault simultaneously with the primary chamber eliminated that option. The pilot had been told this was the most important single target he would ever be tasked against. He had heard variants of that statement before. He did not assign it the weight its speaker intended. He assigned it the weight that 19 years of flying this aircraft had given him. It was a target. It had a geometry, a defense architecture, a weapons employment solution, and a set of tactical complications that his training and judgment were designed to address. Everything else was commentary. He completed his pre-flight checks in 4 minutes and 29 seconds. He taxied to the runway. He waited for the clock. The routing to the target area required 14 hours and 16 minutes of flight time. The aircraft crossed the Arabian Sea on a track that kept it in international airspace until the penetration corridor began, completed its first tanker contact at 2:33 a.m. over the northern Indian Ocean, and its second at 10:08 a.m. east of the Strait of Hormuz. The second contact placed the aircraft at its final fuel state for the penetration phase. Enough fuel to complete the strike, the egress, and the next tanker rendezvous, with a margin that the planning considered adequate, and that the pilot, looking at the fuel gauges after the contact broke, considered marginally adequate, and did not say so because marginally adequate was sufficient, and saying so would have served no purpose. The EW architecture that supported the penetration had been assembled from assets positioned across the Gulf region in a pattern that, taken individually, could be explained by routine operational tempo. Taken together, it was the suppression package for the Alborz mission, positioned over 6 days by tasking orders distributed across different command authorities to prevent any adversary analyst from seeing the full picture at once. The package consisted of 2 EA-18G Growler flights from the carrier group in the Gulf of Oman, a land-based EW asset from a Gulf partner nation's airfield, and a signals intelligence platform whose orbit provided real-time characterization of the Iranian IADS response, fed back to the Growler EW officers on the data link, so they could adjust frequency management as the Iranian operators adapted. The feedback loop was the newest element of the package, developed specifically because previous generation EW support had operated without it, managing Iranian frequency hopping responses with pre-planned countermeasures that the IADS operators had learned to exploit over years of watching American operations in the region. The EW package activated at 1:44 a.m. local time, 43 minutes before the planned penetration corridor crossing. The activation was intentionally early enough that the Iranian IADS operators would have time to begin their adaptive responses before the B-2 entered the defended zone, giving the Growler EW officers time to characterize the adaptation pattern before it became operationally critical. The IADS responded within 90 seconds of the first jamming activation. The long-range early warning radars in the western sector began cycling through their frequency backup options in a sequence that the signals intelligence platform characterized and transmitted to the Growlers in 11 seconds. The Growlers followed the first two frequency shifts within 4 seconds each. On the third shift, the signals intelligence feed showed the Iranian operators pausing, holding on the third frequency longer than the pattern predicted. Holding because they were evaluating whether the American EW system was tracking their shifts in real time. They were correct that it was. They did not know that yet. They held on the third frequency for 47 seconds before shifting again. The Growlers followed the fourth shift in 6 seconds. The pause had cost the Iranians 47 seconds of coherent radar coverage in the western sector. The B-2 was already inside the outer coverage ring when the fourth shift completed. The inner defense ring, the Tor M1 batteries that covered the approach corridors into the Alborz, received their suppression from the land-based EW asset, which was positioned at an angle that allowed it to address the specific frequency bands of the Tor M1 fire control radars without interference from the terrain features that complicated the Growler's coverage geometry at lower altitudes. The suppression was not clean. The terrain was complex, and the land-based asset was operating at a range that placed it at the edge of its effective coverage against the northernmost Tor M1 battery. The northernmost battery's fire control radar experienced intermittent jamming rather than continuous suppression, periods of 4 to 6 seconds of clean operation, separated by periods of 8 to 12 seconds of degraded returns. In a period of clean operation at 2:24 a.m., the battery's radar produced a return that the fire control system classified as a low-confidence contact at the edge of the engagement envelope. The operator reported it. The controller at the Alborz facility's Surface Defense Coordination Center assessed the report against the jamming environment and the track history and directed the battery to hold fire pending correlation with the facility's internal sensor picture. The internal sensor picture, being actively suppressed by the Growlers on the command network frequencies, was not providing useful correlation data. The controller held, the battery held. The contact moved through the engagement envelope and out the other side without triggering a launch. The B-2's passive warning receiver had logged the Tor M1's clean operation windows as they occurred and had presented the pilot with a threat symbol that cycled between active and inactive on a period consistent with the jamming pattern. He watched the symbol. He noted when it was active. He timed his position relative to the battery's engagement geometry against the jamming cycle and made a continuous assessment of whether his current track was sustainable. On 3 occasions, in the 4 minutes he spent inside the battery's notional engagement envelope, his assessment was that the track was not sustainable, that a clean window occurring at the wrong moment in his geometry would produce a weapons-quality track that the controller, freed from the uncertainty of the jamming environment, would authorize. On all 3 occasions, the clean window did not occur at the wrong moment. He continued. The Alborz Ridge appeared on his terrain display at 2:27 a.m. as a solid mass of ground return that filled the lower portion of the scope and that contained, at a specific coordinate in its southwestern face, the aim point for the first weapon. At 2:29 a.m., the Regional Air Defense Command Net experienced an event that the Growlers had not caused and had not anticipated. A power fluctuation in the facility's surface communications relay station caused by a voltage regulator failure in the relay's power supply that briefly interrupted the data uplink between the Surface Defense Coordination Center and the command node underground. The interruption lasted 9 seconds. In those 9 seconds, the Surface Coordination Center lost its picture of the facility's internal sensor outputs and was unable to issue correlation guidance to the Tor M1 batteries in the inner ring. The 9-second gap was not related to the American EW operation. It was a maintenance failure. It was also the 9 seconds during which the northernmost Tor M1 battery, having received no further guidance from the Coordination Center and operating on its own initiative in a degraded communications environment, made the decision to stand down from active search mode to conserve radar emission time, a protocol that its battery commander had adopted as a unit-level emissions control measure designed to reduce the battery's detectability when the coordination net was not providing active guidance. The battery stood down. Its fire control radar went passive. The B-2 crossed the battery's engagement envelope in passive status. The pilot watched the threat symbol drop from his display at 2:28 a.m. and 41 seconds. He noted the time. He did not speculate about the reason. He flew the aircraft. The initial point was at 2:31 a.m. The weapons bay doors opened with the structural shudder that never became routine regardless of how many times it happened. A deep vibration that the pilot felt in the seat and in the rudder pedals, and that his body registered as significant even when his conscious attention was elsewhere. The first GBU-57 released from the forward station. The aircraft pitched up sharply as 15 tons of weapon departed, and the pilot corrected the attitude before his conscious mind had fully processed the departure. A reflex so practiced that it registered as instinct and was, in fact, 11 years of the same correction, performed against the same physics until the correction and the instinct were the same thing. The bay doors closed. The aircraft was already turning toward the secondary aim point. The turn was a planned element of the employment sequence. The backup power vault was 140 meters from the primary chamber but displaced to the northwest at an azimuth that required the aircraft to make a 6-degree heading change between the two release points. The heading change was small enough to execute within the weapon employment sequence without breaking the attack geometry, and the 6-degree displacement meant that the trail time between the two releases, the time the aircraft spent on the adjusted heading before the secondary weapons release conditions were met, was 41 seconds. 41 seconds during which the aircraft was in the post-release phase of the first weapons employment, heading adjusted, bay doors reopening, flying through the inner defense ring on a slightly different azimuth than the one that had been covered by the EEW suppression architecture. 41 seconds during which the Bavar 373 battery on the eastern ridgeline, which had been experiencing continuous jamming suppression on its primary frequency and had been operating in a degraded mode that prevented it from generating a weapons quality track, experienced a 4-second gap in its jamming coverage caused by a power cycling event on the Growler platform responsible for its suppression. A thermal warning on the Growler's port jamming pod caused an automatic power reduction that the EW officer responded to in 3 seconds by manually cycling the pod. 3 seconds during which the Bavar 373's primary frequency was partially clear. In those 3 seconds, the Bavar 373's fire control radar produced 2 returns on a contact that was inside the battery's engagement envelope on a heading that the system's track extrapolation placed over the Alborz ridge at a time consistent with a weapon employment run. 2 returns is not a track. Two returns is the beginning of a track, which is an entirely different thing at the moment. You are watching them appear on your scope. The operator tracking coordinator reported the returns to the engagement controller in the time it took to key his headset. The engagement controller looked at two radar returns, a jamming environment that had been continuously degraded for 40 minutes, a contact heading over his facility's position, and the specific quality of professional alarm that accumulates over a career spent waiting for exactly this scenario. He authorized a salvo launch on the two-return solution at 2:31 a.m. and 53 seconds. The Bavar 373 launched two missiles on a track solution that its fire control system classified as below the minimum confidence threshold for an authorized engagement. The missiles climbed on the computed trajectory. The Growler EW officer, having completed his pod cycling, restored full jamming output to the Bavar 373's frequency band in the same second the missiles were leaving the rails. The fire control radar lost coherent tracking immediately. The missiles flew ballistic on their last computed solution, an arc that carried them toward the airspace the aircraft had occupied when the two returns were generated, not the airspace it currently occupied. Both proximity fuses detonated at 2:32 a.m. and 17 seconds, 400 meters behind the B-2's current position. The concussion reached the aircraft as a low-frequency pressure wave that the pilot felt as a vibration in the airframe rather than a sound. He had been briefed that this was what a near miss felt like in a B-2. The briefing had been accurate. The secondary weapon released at 2:32 a.m. and 6 seconds, 11 seconds before the Bavar 373 missiles detonated. The release completed inside the window before the fire control radar had generated its track solution. The aircraft turned onto its egress heading. The bay doors closed for the last time on this mission. Below the southwestern face of the Alborz ridge, two physics sequences were now running simultaneously and would complete in the same 5-second window. The first GBU-57 struck the granite above the primary command chamber at 2:32 a.m. and 21 seconds. Its penetration proceeded through the rock at a rate that the fusing algorithm had been given accurate numbers for, and its detonation depth placed the explosive yield inside the command node's primary operations floor. The hardened room where the consoles that networked the Iranian IADS had operated continuously for 11 years. The overpressure that the surrounding rock transmitted into the operations floor was not survivable by the infrastructure it housed. The consoles, the servers, the communications routing equipment, the display systems, the fiber termination hardware, the power distribution switchgear, all of it experienced the same event at the same moment, and none of it experienced anything after that moment. The secondary weapon struck the backup power vault surface at 2:32 a.m. and 26 seconds. Its penetration was shallower, the vault was less deep, and the weapon was smaller, and the fusing solution had been computed for a detonation inside the vault rather than above it. The vault's power generation equipment ceased to function. The battery banks that provided bridge power during generator startup received the overpressure and shorted across their terminals. There was no power source remaining in the facility that could support any function in any undamaged space. The facility was not merely struck, it was dark. At 2:33 a.m. across the entire Iranian IADS, the command network went silent. Not jammed. Jammed produces noise. This produced silence. The difference was immediately recognizable to every operator at every console, in every battery and radar station in the network. Jamming fills your screen with garbage. Silence means your uplink is gone. Every operator in the Iranian IADS understood what the silence meant within the first 10 seconds of its occurrence. The backup protocol that the network's designers had built into the system for exactly this contingency, began executing automatically at the 30-second mark, routing command authority to the 3 designated backup nodes distributed across the country, beginning the process of reconstituting the network's integrated picture from the individual sensor feeds that each node could access locally. The reconstitution process would take between 40 and 70 minutes. The intelligence community's estimate had been accurate. The reconnaissance asset used 31 of those minutes. What it collected during those 31 minutes will not be described here. That it collected what it was sent to collect was confirmed by the mission debrief and is the only relevant fact for this account. The B-2 was 280 miles into its egress when the Iranian IADS backup protocols restored partial command authority to the first backup node. The aircraft's data link carried a single confirmation code that told the mission planners everything the code was designed to convey. The pilot noted the time, 3:04 a.m., and began the fuel calculation for the next tanker rendezvous. Outside the cockpit, the Alborz range receded behind him in the darkness, its ridgeline unchanged, its surface undisturbed by anything visible from above. What had changed was beneath the surface, in the dark, in the silence where the network had been. The numbers that closed the package: 14 hours and 16 minutes of flight time. 1 GBU-57, massive ordnance penetrator against the primary command node. 1 secondary precision weapon against the backup power vault. 2 Bavar 373 missiles launched on a below-threshold track solution, both detonated 400 meters behind the aircraft. 0 radar tracks generated in the integrated IADS. 9 seconds of maintenance-caused relay failure that produced the emissions control stand-down that cleared the final approach. 31 minutes of reconnaissance collection executed inside the IADS reconstitution window. 0 aircraft lost. The command node that had networked the Iranian integrated air defense system for 11 years was rendered permanently inoperable. The network it had sustained did not immediately cease to exist. It became something qualitatively different, a collection of capable individual systems with no common picture, no shared engagement authority, and no coordinated brain. What had been an architecture became equipment. An integrated air defense network is not the sum of its sensors and missiles. It is the connective tissue between them, the shared awareness, the coordinated response, the decision architecture that makes individual systems greater than their individual capabilities. Remove the connective tissue and the systems remain. They can see. They can launch. They cannot think together. And a network that cannot think together is not defending airspace. It is occupying it. The Alborz Ridge keeps its silence. What it no longer keeps is the network.